Hi students, in this video, we will be solving question number 28 from exercise 5.1 of continuity and differentiability chapter from 2nd PU syllabus. So this is the question. This is a very important question. In Karnataka PU board exam, in part E of the question paper, the question number 49 and 50 will carry a marks of 10 each with a split like 6 plus 4 marks. As per the blueprint, it's clearly specified that the 4-marker question will be from continuity. Either this can be 49B question or 50B question. So it is a very important question. Please do understand and learn. So let us check the question first. Find the value of k so that the function f of x is equal to this. This is how the function is defined. Is continuous at x equal to pi. Now why are we talking about only at pi? The reason being the function changes its behavior when the domain element is pi. So for domain element x greater than pi, the function is behaving as cos x. When x is less than or equal to pi, the function is kx plus 1. This is how the function is defined. When we have to evaluate the limit as x tends to pi, when we evaluate LHL, it is always when x is less than or equal to. So it is this function, and when x is greater than pi, this is how the function behaves, and for RHL, this is the function to be considered. Now, let us answer this question. Given that the function f of x is continuous at x equal to pi, as per the question, it is clearly given that the function is continuous. So we can use the definition. So what is the definition of a function to be continuous, or condition for a function to be continuous? It is like limit of f of x as x tends to a minus is equal to limit of f of x as x tends to a plus is equal to f of a. So LHL is equal to RHL is equal to f of a. So if we apply this definition to this particular sum, it is LHL is equal to RHL is equal to f of pi. So limit of f of x as x tends to pi minus equal to limit of f of x as x tends to pi plus is equal to f of pi. That is, as x is tending to pi, we are evaluating the LHL and RHL, and also we are finding the value of the function at x equal to pi. So since it is continuous, we are already equating the terms, equating it that LHL and is equal to RHL and equal to f of pi, since it is already continuous. Now first, let us find f of pi. F of x is equal to kx plus 1 at x equal to pi. How did we decide on this? It is given here. As per the function is defined, for x less than or equal to pi, equality is also there. For when x is equal to pi, the function is f of x is equal to kx plus 1. So we are considering f of x is equal to kx plus 1 at x equal to pi. Pi in place of x, which will give us f of pi is equal to k pi plus 1, that is equal to k pi plus 1. So this is f of y. Now let us find the LHL. That is, LHL is equal to limit of f of x as x tends to pi minus. Now that is equal to limit of kx plus 1 as x tends to pi minus. Why did we decide that the function is kx plus 1? Because x is tending to pi minus, that is left hand limit. That means the value of x will be less than pi. So whenever value of x is less than pi, the function is defined like this. Now for RHL, what are we going to consider? Because for RHL, x will be greater than pi. So we are going to consider f of x as cos x. Is it clear? Okay. Now we'll replace x by pi minus h. Then the function will be limit of k into pi minus h plus 1 as h tends to 0. Why did we write pi minus h only? To evaluate LHL, we have to check what is x is tending to. Then x is tending to pi. So it is pi minus h, where h is a very small positive quantity. What does this mean? This means x is little less than pi but close to pi. That is what it means. Now it doesn't take any indeterminate form. So we are substituting the limit as h is equal to 0, which will give us k into pi minus 0 plus 1. That would be k pi plus 1. So LHL is equal to k pi plus 1. Now we found f of pi and we have found LHL. Now we are finding the RHL, which is f of x is equal to cos x is the function that we are going to consider for RHL. So for RHL, limit of f of x as x tends to pi plus, that is equal to limit of cos x as x tends to pi plus. Now for RHL, x is little more than pi. So it is limit of cos of pi plus h as h tends to 0. Pi plus h is, the value is little more than pi. So application of the limit gives us cos of pi plus 0, which is cos pi. Cos pi is minus 1. We already know this. This can also be understood as, instead of substituting for h as 0 here, we can also understand this as cos of pi plus h is, what is the form? Cos of pi plus theta. So this is in the third quadrant. In third quadrant, as per ASTC rule, cos function is negative. So this will be minus cos h. So if we apply the limit and then substitute for h as 0, then it is minus cos 0. That will be minus 1. So it is same as this. You can understand in both the ways. So as per the definition, we had written the equation 1, that is LHL is equal to RHL is equal to f of pi. We have found all the three values now. We are substituting there. K pi plus 1 is equal to minus 1 is equal to K pi plus 1. So this will be K pi plus 1 is equal to minus 1. We are considering any two parts of this. So on simplifying, we get K is equal to minus 2 by pi. So the value of K is minus 2 by pi, for which the function is continuous. Since it is already given that the function is continuous, the value of K is minus 2 by pi. For this value of K, the function is continuous. That is what is the meaning.